My name is Jimi Shanahan, and this is Eric Glover, and we'll introduce ourselves in a moment. But we'd like to tell you about our collective experiences in web search. And web search is an interesting field that's been around for a long time, going back to the early 60s, in fact. And it's such an interesting field that it has been perfectly teed up from a machine learning perspective, because metrics and measurement and evaluation has been the core focus of information retrieval and web search. And who could ask for a better setting from a machine learning perspective to have labeled data? So anyway, we're going to talk about our experiences at various large-scale search engines over the past 10 years.
Just forward.
Is it on?
Yeah. All right.
All right, we're live. Great. So,
What?
weird. It's in here.
Uh-oh.
Sorry.
His name disappeared.
Somehow, this is a slide about me, by the way. So I've been working in the field of information systems and machine learning for 20 years at this point. And more recently, I've started a boutique consultancy in San Francisco focused on data modeling and machine learning for various corporations, including SearchMe, AT&T, Adobe, Ancestry, and so on. And so the common theme of these companies is that they have very large data sets, and they want to leverage those data sets in order to build intelligent decision-making systems. Today, we'll tell you about a ranking system for a search engine. It's yet another intelligent decision-making system. And by way of introduction, I've worked at a variety of places, including Xerox Research, and more recently, I've been a chief scientist at a company called Turn. It's an online advertising network demand-side platform. And then, this is Eric. I think we got a full slide for Eric. Eric, do you want to sit? So Eric has also had a very eclectic career to date, and in the sense that he's worked at Ask Jeeves, and he's one of the chief scientists at Ask, and at SearchMe as well. We worked together at SearchMe actually, and currently he's the chief scientist or fellow at Quixie, this new app search engine that Dan introduced earlier. And so Eric's focus has been in the field of machine learning, text classification, and applying them to various information science problems. So we thought we'd structure today's talk as follows. First of all, I'll give you some introduction to the field of web search and the types of problems we tackled in this area. And so one of the key problems to tackle here is relevance. Once we get relevance sorted out, we're all teed up to use any of a variety of machine learning problems, including TreeNet approaches. And web search in particular is a very unique problem in the sense that we're starting from scratch sometimes. Some of the problems we heard about earlier today, one was able to glean data from behavioral systems. So, for example, we had a talk from Visa this morning. So if there was credit card fraud, then you know it's credit card fraud. It's been flagged already by a human, or if it's not fraud, it's also flagged as not fraud. So the data is labeled automatically, if you like. Here we have to start from scratch in some ways and label that data. And typically we need tens of thousands or hundreds of thousands of examples, and this is an expensive process, and it's a pretty unique to this search problem. Then we'd like to segue into telling you about Quixie, this app search engine, and some of the peculiarities of app search and how machine learning is being leveraged within this problem framework. And as usual, there are a variety of approaches one can bring to bear to problems such as ranking. And we'd like to tell you about other alternatives that we've looked at in comparison to approaches such as TreeNet. So search as a product, I guess we're all very familiar with it. We can think of search engines such as Google. We can also think of search engines such as SearchMe. It's a search engine that both Eric and I worked at in developing. And this search engine was a little bit different to the normal 10 blue links. The user experience was very different in the sense that the results were presented as screenshots of the pages that made up the results page. And you can flip through these results very much like a photo album. So when it comes to data modeling any problem, there are 5 or 6 basic steps. And you probably have seen these steps over and over the last couple of days, and you probably use them in practice at your work as well. But just to be on the same page here, the first step in understanding how to leverage machine learning and statistical modeling in practice is we need to understand our problem domain, and we need to pull out a problem that we want to tackle. Then we want to collect the requirements of such a system and, if possible, the data that might enable us to learn such a system.